I'm Jason Gallup and welcome to the Roldorf Cafe. A couple of days ago, I got to sit down with Albert Zeller of RC Tritec. He is the CEO of this Swiss Superluminova company, and we had an in-depth conversation about all things Lume. I got to ask him lots of questions about his products because they're not just manufacturing Lume for watches, and many of the well-known companies that you've come to know and love, but also doing other things for the commercial industry that require luminosity. This is a very, very interesting conversation because it's a very diverse company. They're not just making Lume for watches. They have other commercial applications for their products too. So thank you very much for joining me, and I hope you enjoy the interview.
At first, my dad told me, you need to be able to speak French, otherwise I won't let you start in the company. As you know, in the Swiss watch industry, the industry is mainly situated in the French-speaking part. So I first started with an exchange in France, and laterwards, I began working in production and made my way up, where I ended as a head of luminous pigments. And then 8 years ago, we decided that I can take over the company.
So this truly is a family business. Who in your family started the business, and where did the name RC Tritec come from in the end?
So it was my great grandfather. He was like a pharmacist, coming from a family who makes some pharmaceutical compounds, plant-based. And he decided 90 years ago to found his own company with a high-tech material. High-tech by that time was not like nano surface treatments or blockchain. It was simply radium. Radium was known that it's an interesting material. You could put radium into needles, put these needles into tumors, and then irradiate everything around the needle, so you could basically treat cancer, but only in a certain area. And people told themselves, well, if it can cure cancer, it must be good for your health. And then my great-grandfather was also fascinated by that, and started doing applications in that field. So we started first with drinking cures, basically glasses where you had a radium source in the bottom. And radium is falling apart to radon. And the radon is a precious gas. Huh? I would say, it's called like that, I think, in English. So people could drink water with the radon in it, which was perceived to be healthy back then. And because we were working with the radium, we were first called Radium Chemistry Zeller Limited. So over the years, of course, we stopped working with radium, and you cannot pick up the phone and say, this is Radio Chemistry Zeller speaking, even though you have nothing to do with radium anymore. So that's why we decided to say, okay, we changed the name to RC, Radium Chemistry, Tritec, Technologies.
Yes.
So basically nowadays we're producing luminous compounds called Swiss Superluminova, which are not radioactive anymore. We are working a lot in the field of all kinds of security applications, such as the exit sign, those things. But also we have continued working with tritium for pharmaceutical application to label interesting compounds, to track them in your body, to find out how they work, where they work, how they are excreted, and so on.
Oh, wow.
So you see, basically it started with the radium-activated luminous compounds after the drinking cures. And from there, a wide tree developed during the last 90 years.
I see you're wearing an IWC.
Exactly.
And it's your product in there.
Of course, like nowadays we have the pleasure that we are able to deliver to all the famous Swiss watch brands our materials. So basically, uniquely, so we do not have a lot of competition who can reach the quality standards we have. But as you know, like if I'm talking about the entire Swiss watch industry, there are different types of customers, different groups, different price ranges. And of course, there we have to give them a lot of technical support. Or not only like providing the raw material, we also provide like binders, we develop the application methods and so on, so that basically with our know-how and our material, our customers have the chance, to produce their dials and hands by themselves and to make a living with that. And of course, we can also live.
Yeah, absolutely. So what would you say are some of the key milestones in RC Tritec's history?
Mm-hmm. Well, basically, I think like the changes of technologies, they have to be mentioned. Like it all started first with radium activated luminous compounds. So basically, we mixed zinc sulfide with radium. And with the irradiation of radium, the zinc sulfide was glowing. But then it was found out that radium is not so healthy. So basically, then the first milestone came, which was that we got like as a the first company worldwide, the import license to the American market with tritium activated luminous compounds. So in the 50s, the watch industry was not happening in Switzerland, but in the US with brands such as Timex and so on. So we basically started working with the watch industry in the US, and from there found our way back with this watch boom to Switzerland with the tritium activated compounds. And I would say like then the next milestone was definitely stopping with the tritium activated compounds because my father was kind of forced by the Swatch Group by the end of the 80s to stop working with tritium in the watch industry. The Swatch Group, they told him, well, it's hard to tell the people that their watches are radioactive, but they're not harming the people. Like you had the accident in Chernobyl, you had the Cold War, and people didn't really want to have radioactivity on their wrists anymore. So he found an interesting material, a ceramic powder, which he handed over to a partner company in Japan, which is called Nemoto. And the Japanese partners, they found out how to improve this material. And then we decided to found a joint venture where basically our Japanese partners were supplying this material to the Japanese market. And we took care of the Western watch industry. And here in the Western watch industry, the material is called Swiss Superluminova. So that was like the launch in 94. And I would say like from then, basically, we had quite a steep success curve where we launched more and more different materials, different emission colors, new technologies in applications. So nowadays, we're also able to produce like entire pieces made of Superluminova, which can be used for hand styles. We call them Lumicast blocks. I can show them laterwards.
Over your lifetime, you've seen a huge amount of change. I mean, not only have you understood through your grandparents and your father the radium aspect of things, the change into tritium and that world, and then you've ventured into this world of ceramic-based products which you can color, and I think that for from an aesthetic point of view to the end user, the watch wearer, is the thing that then becomes most fascinating, right? To actually have black lume, right? It's pretty incredible. How did you actually get to that point of deciding that you would actually start to use different colors and experiment with that?
Well, basically, like the colorization processes were already started in the tritium times. There you had some standard colors, which were like C1, which was very white, C3, yellowish or uncolored, C5, which was more bluish, and so on. Then you had like a bright red, a dark red, bright yellow, dark yellow, and that was it by that time. And then, of course, like if you have these standard colors, people get creative and tell you, well, I would need like a red in between the two. Could you also do something like that? So we started like in an old lab doing also these colorizations, of course, under rather harsh safety measures because it's radioactive material. And when we finally stopped working with the tritium activated compounds, then of course like the doors went open. So like you could do whatever mixtures you wanted to do, like you could do it in very small batches as well. And since then, like it really took off. Like I would say, like this started, I would say towards like the 2000s, where like people really got creative with it. And in the meanwhile, we have more than 6,000 different colors existing. And if a color does not exist, we will develop it within like 10 work days.
Yeah, I was watching a video that you created with the Naked Watchmaker and Peter Speak back then, and there was a segment in it where you were actually colorizing for a special color of green. What a fascinating thing to actually do, to have that demand on that side, to then become creative to the point to be artistic with this. It's incredible.
I mean, this is a very good example. You have like the bracelet, which has to match like the dial, the hands, and the case and everything. This was, of course, not possible before, huh?
When thinking about the color red, you can't help but think of Apple's and Ford Mustang motor cars, for example, right? Like these things stick in our colors stick in our head and our memory. It can make or break a product, and especially that particular watch. It's astounding how you can get that close match with the case to the actual lume on the dial. Yeah,
you have to nowadays. Like 20 years ago, red was red, which was okay.
Yeah.
But nowadays, you know, by yourself, like people are more and more demanding on quality, and a watch is something. Yeah, you pay a certain price for it, so you also can expect a certain quality, and of course, we have to follow that.
So, what do you think were some of the big challenges, sort of during these transitions, going from radium to tritium, and then the new product of Swiss Superluminova? What were those challenges?
I think like it's the engineering for the process itself. So like the Superluminova, for that we had to construct completely new furnaces. And these furnaces like needed to be tested, then like finding all the right parameters, then how to grind down the big ceramic blocks into powder form, what powder works best, and so it was basically a development of a new material. Huh? On the other hand, things got also easier because you did not have to take care of all the licenses and the measure urine samples of the workers to check if they have incorporated too much radioactivity. All these things, like, yeah, it's a lot of engineering, but as a scientist, this is also like the fun part.
Yeah, that must be a very interesting thing for workers that come to be in a company like RC Tritec in the past, where they know the dangers of radium, and then sort of getting into a workforce where you are working with tritium and dealing with that. I mean, the precautions must have been immense, and you've got people's safety that you're having to look after, right?
But you should also not forget that like the precautions got more and more severe over the time. So when the whole thing, the radium colors were discovered back then, it was considered to be healthy. Like people were working brushes and putting it into like skin cream, toothpaste, and whatever to have like bright teeth. So when it was found out, of course, like you had like the first step there, and then like the more you learn, the more cautious like the authorities get. So of course, we never wanted to play around with that, but the process, of course, gets more and more complicated. But it's same with other materials nowadays. Like you find out about the dangers, and then you have to adapt.
Your material is ubiquitous through the Swiss watch industry.
Mm-hmm.
Who would you say your competitors are for luminous materials?
Like we have a competitor, which is a very good friend of ours, and having a joint venture with us together, which is of course Nemoto. But Nemoto, basically, they're responsible for the Japanese market. So all the Seikos, Casios, Citizen, and so on watches, they're supplied with their material. They're also luminized in-house. So basically, the Nemoto offers the application in-house, whereas like we sell the pigments to the market so they can be applied to the component itself. And of course, like as every other good material or product, you have like some people who get in China, for example, who get inspired by your success, and they also try their best. Sometimes they do not show a lot of fantasy when they give it the same name as we sell it, for example. But counterfeit products are everywhere a problem.
Yeah.
The only difference is that like we have the better performance at the end. We can reproduce the quality the people are asking for. We do not play around with these parameters and the trust of our partners. Yeah.
That brings up a very good point. Reproducibility. One thing is to develop a product and have people love it. But then if two people are wearing the same watch and they're comparing things, as collectors and enthusiasts will do. Hang on a second, why is that one not glowing quite as much as mine? That repeatability is very important. How do you achieve that?
So we have quite a strict quality control. So it's like before our material leaves the house, it's 3 independent people checking the material on its properties. So like the first tests are tests like grain size distribution. This is more for the application itself, so that the flow in the binder is the same, the drying process is the same. But up to parameters like chargeability, emission color, which should be the same, like wavelength which charge the pigment itself, but also like duration in the dark. So like these parameters are all checked. And then when they get colored as well, we do a check again where we check like the color on different lighting conditions, warm light, cold light, UV influenced or fully UV light. We check with an original sample. So it is always the same as the original sent sample. And this is done for every single gram we send. Because like, imagine buying like a Patek Philippe or whatever, and finding out that like your hands are not activated the same way under certain light conditions. You don't want to have that. And I think this makes a difference to let's say, larger scale producers of luminous materials.
Is there a particular color that you find most challenging to have that repeatability? For example, is black loom a very difficult thing to maintain luminosity over different batches?
No, like black is not as sold. But I would say like there are colors who are rather sensitive to smallest changes. So like all the grayish or like the beige colors, if you add just a little bit more of one colorant, like the look directly changes. And also they are then like in the application itself. So layer thickness, for example, it covers differently. You see the underground shine through. It's the afterwards also like the concentration of the pigments in the binder who play a role, like how much something is covered. So these colors are a little bit more sensitive, like the grayish and beige colors. Yeah. With 1 single gram of our pigments, you can make in between 100 to 300 dials. Huh?
I heard that, and that's pretty incredible because when I'm trying to relume hands, and I'm doing it the old-fashioned way. I'm not using compressed air applicators and stuff like that. It's the way we did it at WhatStep. Put it in, mix it up, try and find the right consistency at that point, and then put it onto the hand. There can be very little in the way of repeatability of doing it that way, doing 2 sets of hands. And it seems like the amount of material that I would use, there's a lot of wastage. So it's when you say that for 1 gram of material, that's pretty incredible.
The actual cost per timepiece is not as high anymore if you start dividing it by 300.
Yeah.
It's more like the work cost itself. Huh?
Yes. Yeah.
Who is causing the cost? Because like somehow the material has to get onto the component. Yeah.
When it comes down to sourcing your materials, are there challenges there, or are you making most of the material yourself?
So basically, the pigment itself is produced 100% here in house. But of course, like we have to get certain colorants, which we don't produce in house, like which we have maybe developed with the manufacturers. And the raw materials, of course, like rare earths. We don't have a rare earth mine in our garden, so we have to get it from somewhere else. And they are basically, because we only produce a very small amount of kilograms a year, we have to purchase stocks, because like the manufacturers of rare earth materials, for example, if they're not interested selling you 5 grams of europium oxide or something like that, like they want to sell kilograms. So we are basically forced to purchase way more than we actually need.
Yeah.
Just to get to the minimum order quantity. But on the other hand, this makes us very much crisis resistant, because like if we have to purchase like 1 ton of something,
that would
we can work for years, and which is basically luck on one side. On the other hand, we have to take care that like the manufacturer does not stop with it without letting us know.
Yeah.
Because we're just too small. That's the thing.
What have been the most interesting applications that you've generated product for? What are the applications that interest you the most?
Maybe like it's depending on my point of view a little bit, but I always like projects where we get involved quite a lot.
Yeah.
So for example, what I loved was like with barrel hands, like a development where they have constructed a watch to go into outer space without gluing components on their watches. Because like if you leave the space station, you have like enormous the temperature differences in between, like being in the shade or in the sunlight. This can be like a few hundred degrees. So we have developed there like a molded piece, an index piece, which was then like clacked in like a sandwich into the dial. So you did not have to glue. So it does not get ripped apart under these temperature differences, which was quite cool to also follow all these like tests they did with the NASA. And then, of course, for example, with IWC, the Zeller Lume watch, where they have made like two prototypes, where like the entire case of the watch was like basically a ceramic case made out of Superluminova, which is of course like the coolest thing we could see.
Yeah, absolutely. What do you think are the emerging trends with the use of your products in watchmaking that you're developing for?
Yeah, I think like we're slowly starting to go out of the only practical use. So readability readability in the dark is of course what we are enabling the brands or the person who wears the watch at the end. But more and more brands start to play around because it is a certain magic material. Huh? We all remember it from our childhood, the little stars in the rooms. Yeah. So like the brands are more and more starting to use it in a aesthetic way. So for example, Stepan Sarpaneva with the Moomin watch, where you have like all the glass in the back in different light. You have like Beauvais, who has like miniature paintings with Superluminova on their dials, up to Tissot, for example, who has like the Grandizer PRX, where you have like these robots starting to glow in the dark. So I think this is one thing that like the brands get more and more creative to really play around with the whole thing. Up to like IWC, who said, okay, we're going to make like an entire watch made out of Superluminova. And the other thing is like what we see and what we also try to force a little bit is like the application itself. So until now, like mostly it was the luminous materials were applied by manual application with the syringe. You could do silk screen printing, more and more pad printing nowadays as well, which gives you sharper outer angles and edges. And what we are doing now is also like the molded pieces. So to make a negative mold, which is then infilled with Superluminova, highly concentrated, and then directly unmolded on the watch component. So we talked about SIN a few minutes ago. So for example, SIN is using this technology quite a lot. So there's like full face dials, which are like with a molded Superluminova on top. And of course, like if you have more material applied, this also means more luminosity. So like these dials, they're crazy bright. I have some examples of things we made, like just to maybe show you a little bit what is possible. So for example, like the Tudor Black Bay Pro,
Yes.
So it looks like screen printed from the front, very classical design. But if I now start to turn the dial, you see, you have like really a block applied,
Yeah.
So a block is bigger volume. It's also aesthetic-wise looking nicer. And if we talk about the glow, it's just like incredible bright. So you'll probably see that after 2 days. Then of course we can also do like super fine things in the meanwhile with these blocks. So you do not necessarily have to do like pad printing. You can really like apply such a block. Something rather rare,
Yeah, really.
And you see,
Incredible.
still rather bright, even though like the surface is rather small, which was applied. And then of course,
that's
that was a
incredible.
fine one.
Yeah.
That's the opposite.
Yeah.
The entire dial as a block, you can see.
It's a block, yeah.
Yeah, applied to the dial. That one you will probably also see the day after tomorrow.
Yeah.
And the molding system itself like has some advantages because you can start playing around with the surface. So you use a negative mold, which is then infilled, and you can basically shape the negative mold. So, for example, this is something super nice we have also done. It's like a moon phase. And now I try to show it a little bit with reflection. Maybe you can see it. So the moon itself, you can see the craters in the moon.
Oh, okay. So, yeah, that's something we can't quite see through the camera, but it's
that. Let me check quick. I'll switch off the light quick.
Yeah.
Of course. So you see, like you can really get creative with that. And the only thing is like we sometimes also have to like show the people a little bit to think out of the box, to rethink the methods they're doing, and then you can really create beautiful things.
Yeah, absolutely. We started off the conversation just before we started recording, and you were talking about technologies to clean up radium and tritium. Can you tell us a little bit about that?
Basically, like cleaning up radioactivity means like separating it physically from materials where they are applied on. So it means like, for example, a dial. Basically, you have to take the watch apart in a box, which is ventilated. You don't want to inhale like dust, radium dust. And then you take off the dial, and the dial is then really like manually with a single needle, like it's taken off the surface. Then you put it like in certain baths to decontaminate like the rest, to kind of solve off the surface. Then of course you have like a scratch dial, which is then repaired like mostly manually, and maybe also applied with Superluminova in like a brownish looking grade to make it look as original as possible. But the thing is like don't try to do it in an unprotected area by yourself. This is our big recommendation. And I think also by law, at least in Switzerland, you're not allowed to do that.
When I worked for Rolex, we would often have to relume hands. And at that point in the 80s, we were reluming with tritium. So we'd be knocking it out of the handle, taking it off of the dial. There were no special precautions for it. We looked at it as being such a small amount of material anyway. Much to the chagrin of enthusiasts, if they've got a watch with a tritium dial, they send it into service for one of the service centers. They want to change it, even though it's not looming.
Change the watch. Like we often get asked, actually, like I would say at least once a year, by someone who asks like if we have like radium for sale. Just because of that. But of course, like we're not allowed to sell radium, even though we would have some, to someone without a license. Like in Switzerland, for example, there's a big problem with all the buildings where people have been working at home with radium. Like back in the past, like they gave like private people working in the companies material back home, so they could like luminize like hands and dials on their kitchen table while having the children playing around in the garden.
Yeah.
And yeah, of course, like when you finished your work, you took the rest and just put it in your
down the drain. Yeah.
So basically nowadays they really have to kind of cut out like all the pipes and to grind off manually from the inside the radium residues. And like even my dad told me like when he like my great grandfather, he started in the basement of his private house with the first experiments with the radium paint.
Yeah.
And he told me like as a child it was like the greatest thing to visit grandfather and go into the basement, and you didn't even have to switch on the light.
I was working on a watch recently, a Rolex from 1940 or so. When you look at the dial and the hands, there's such a small amount of radium on that dial. Yet the moment I put a Geiger counter anywhere near it, the Geiger counter was getting scared. It was beep, you know, the alarms were going off like crazy. But then I put next to it a Cyma watch from one of the original Dirty Dozen.
Yeah.
And those were radium as well. It didn't, far more surface area for the material than the Rolex, and it doesn't give off anywhere near as high a reading. So I think the potency for the Rolex Lume must have been very, very strong.
Yeah, so they must implemented a lot of radium into their material, higher concentrated. That's the dangerous thing about radioactivity. You do not see it, you do not feel it, and it's there, and it can harm you. Of course, like there are not really a lot of cases about which I know, or I don't even know about one single case where someone was dying because of his watch.
Yeah.
But still, like I always try to compare it a little bit with the tempo limit in a car. Of course, you can drive 100 miles an hour in like a 30 miles zone. You probably can survive it, but the chance that something happens, it's just like higher than if you stay below a certain speed. So
yeah. Do you have any parting comments about radium watches, tritium watches, and Superluminova that you'd like to impart on people that are watching this?
So I think like one thing is like just don't open up the watches by yourself, please. Like let a specialist do it. It's better for your health. And on the other hand, like I think nowadays you don't have to worry anymore about your health at all with our new materials. I had the Superluminova. And like, I hope that at least after this conversation, everyone enjoys their watch even more because you have learned a little bit about luminous pigments. And if ever you guys are in Switzerland, like let us know. We're in the eastern part. It's also a nice place. And for watch enthusiasts, like our doors are also open. So don't hesitate to get in contact with us. And
fantastic. Thank you so much, Albert.
Thank you. And have a great evening or
just the start of the day now.
So
yeah, for sure. Okay. Thank you. And we'll talk soon.
With pleasure.
Hello everyone, this is Jason, and I want to thank you for being with us today listening to the Roldorf Cafe Podcast. You can hear more of our shows and when they're released on Instagram and our website. We cover many topics about watches, the industry, and the brands we're most passionate about. You can find the Roldorf shop at 307 West Cordova in Gastown in Vancouver, and we'd be delighted to welcome you and talk watches. Visit our website for more information at roldorf.co.